Hi students, welcome to today's class. In this today's class also, we are going to discuss a very important points and concepts. So without wasting our valuable time, so let us straight away start our class. So in this video, first I am going to start some notations which are useful in our further course. What is the notation means? Let the algebraic expression x square by a square plus y square by b square minus 1 be denoted with the symbol s. X square by a square plus y square by b square minus 1. Don't misunderstand that. It is not is equal to 0 is not there. So remember that. Only x square by a square plus y square by b square minus 1. Let us take 2 points, distinct point x1, y1, another point is x2, y2. Then the notation, so the notation is x1 by a square, the expression y1 by b square minus 1. It is denoted with the sign s1. So this is a second degree expression. Algebraic, this is a first degree expression. Why? Because here x1, y1 is a pointer, we will substitute here. Now the algebraic expression x2 by a square plus y2 by b square minus 1, it is denoted by the symbol s2. Okay now? Right. Another symbol is x1 x2 by a square plus y1 y2 by b square minus 1. It is denoted by the sign 1 comma 2 s12. And the last and final, so this is x1 square by a square plus y1 square by b square minus 1. This is denoted with the symbol s11. So in our due course, wherever s1 is there, that indicates x1 by a square plus y1 by b square minus 1. Remember that here is equal to zeros are not there. Generally students will have a false notation, means s1 means s1 is equal to 0, not like that. So s means here only x square by a square plus y square by b square minus 1. Okay na? So s1, s2, s12, s11 or s22 also, that is x2 square by a square plus y2 square by b square minus 1. Okay na? Don't say that is equal to 0. So it is just a notation to make the to understand the concepts in a simple way. Okay na? That means wherever if you get an expression that x1 by a square plus y1 by b square minus 1 is equal to 0, instead of remembering such a long expression, simply if you remember that s1 is equal to 0, that will be very easy. Okay na? Now basing on this concept, let us start the one important concept. Okay na? Welcome back to this concept, that is interior and exterior of an ellipse. So the interior and exterior of an ellipse can be easily defined. Why? Because ellipse is a closed figure. Just like a circle, ellipse is also a simple closed figure. Therefore, we can define easily what is interior and what is exterior. Okay, now even a small child also can define. So okay, let us take this is a, so this is a focus SS dash. So coming to the definition, the region in which the foci S and S dash lies is called interior of the ellipse. So wherever S and S dash is there, or major and minor, this S and S dashes are there, so that is called interior of the ellipse. Okay na? Just like center also, wherever center lies, that is called interior of the ellipse. So and opposite of that is exterior. This is interior and it is exterior of the ellipse. Okay, so whatever may be the which is not interior, it is called exterior. Okay, on the ellipse means the point which lies on the this ellipse is called on the ellipse. Right. Now our topic is, given a point, so there is an ellipse x square by a square plus y square by b square is equal to 1. there is an equation of the ellipse. There is a point P x1 comma y1. If a point P x1 comma y1 lies inside the ellipse, what is the condition? If it lies exterior of the ellipse, then what is the condition? Let us see that. Let us take P x comma y be general point on the ellipse. Let us join SP and join PCP also, so that the length of the SP perpendicular, let us say that it is a perpendicular for our convenience sake. SP is perpendicular to the axis and CS is horizontal line. Now let us take a point Q x1 comma y1. Okay now, right. Let us, otherwise if you can join any point, otherwise you can take a PN, otherwise it is a S focus. Any point, no need to, it coincides with S, you can draw the perpendicular PN on the axis. Now this equation can be written as x square by a square plus, so here this your Cn is x and Np is y according to the coordinate system. So in place of y, can I write down Np square by b square is equal to 1. So here x square by a square plus Np square by b. So in place of y, I can write down Np, that means vertical distance. So from this, Np square by b square is equal to 1 minus x square by a square. Just put it like that. Let us take a point Q x1 comma y1. Let us take a point Q x1 comma y1. Q x1 comma y1, any point. In the which lies inside the, let Q x1 comma y1, which lies interior of the ellipse. It lies interior of the ellipse. Let us say that Q lies on the PN. Q lies on the PN, right. From the diagram, it is easy to say that, it is very easy to say that Qn is less than Pn. Okay now? Since it lies, Q lies inside the ellipse, Qn is less than Pn. Okay now? Right. That means Qn by b square is less than Pn by b square. Qn by b square is less than Pn by b square. What is Pn by b square? Why? Because b is a positive quantity, b square is a positive quantity, we can divide, so that your inequality will sign won't change. Qn by b square less than Pn by b square. What is your Pn by b square? This is 1 minus x square by a square. So this is a Qn by b square is less than 1 minus x square by a square. What is your Qn? Qn is nothing but y1. y1 by b square is nothing but 1 minus x square by a square. See here, let us take a Q is an arbitrary point. Q is an arbitrary point. Any point you can take inside that. So we will get that y1 by b square is less than 1 minus x1 square by a square. We can take. So x1. So here the coordinates of this Q is x1 only. So this coordinates of Q is x only. To be frankly speaking, the coordinates of Q is x only. Why? Because here Cn and for the P and Q same x coordinate, only the change is y coordinates only. Okay now, so if you take Q as a x1 and y1, so we can put like that as a y1 and x1, so nothing wrong in it. So bring all the terms to one side, so you will get x1 square by a square plus y1 square by b square. So you can square it, no problem. Here you can square it. Qn square by b square is less than Pn square by b square. Square it, no problem. Then also it is less than. So, x1 square by a square plus y1 square by b square minus 1 less than 0. So, minus 1 less than 0. Okay, now. So, this is nothing but just now we told one notation, that is S11 is less than 0. S11 is less than 0. That means, given a point P, if your expression is x square by a square plus y square by b square minus 1, that if S11 is less than 0, that means substitute this x1 and y1 point here. If this quantity is less than 0, then we say that quantity, then we say that the point Q lies inside the parabola. If it lies exterior, that if it is lies outside the parabola, what happens? Let us put Q here, x comma y, x1 or y1. So, if you observe here, Q1 is greater than Pn. Q1 square is greater than Pn square. Q1 square by b square is greater than Pn square by b square. So, this is also Q1 square is greater than. So, here you will get greater than, here you will get greater than, and you will get greater than or equal to 0. Obviously, if the point of P lies on the ellipse, S11 is equal to 0. S11 is equal to 0. So, very, very easy concept this is. So, on the whole, so given a point x1 comma y1 and S is equal to x square by a square plus y square by b square minus 1, then if S11 value is to be negative, then the point lies inside the parabola. If S11 value is to be positive, then the point lies outside of the exterior of the parabola. If S11 value happens to be equal to 0, then the point lies on the on the ellipse. Okay. I hope that you understand this concept. Let us go for next concept. Welcome to this concept. So, here we are going to see auxiliary circle. Okay. Now, after that we will see the what is eccentric angle. Okay. Now, let us see what is auxiliary circle of an ellipse. First, to take the one ellipse, that is here x axis and y axis. Okay, there is a horizontal ellipse, you can take vertical also. So, this is a ellipse, okay, whose equation is x square by a square plus y square by b square is equal to 1. Here a greater than b, right. So, here you take it as a and it is here a dash. Now, the definition of auxiliary circle is, the first definition is very simple definition. The circle whose diameter is major axis of the ellipse. The circle whose diameter is major axis of the ellipse is called the auxiliary circle. Here what is the major axis? This is a dash is the major axis. Taking major axis as the diameter, draw a circle. That circle is called auxiliary circle. So, this is the diameter. So, this is the auxiliary circle of the ellipse. So, okay, right. So, this is a ellipse and I am taking a dash as the diameter. Therefore, the circle whose diameter is major axis of an ellipse is called the auxiliary circle of the ellipse. Okay, now what is the equation of this auxiliary circle? Sir, anybody can say. The first point is, for both ellipse and the auxiliary circle, center is same. Coming to the length of the major axis is 2a, therefore, the length of the semi major axis is a. That means, from a to a dash, the length is 2a, but only we are taking as a radius is a. Now, we know the equation of the circle whose center is 0, 0 and radius is a as x square plus y square is equal to a square. This is the equation of the auxiliary circle. x square plus y square is equal to a square, where a greater than b. Sir, what happens if it is a vertical ellipse? What happens? Let us see that vertical ellipse. Okay, so that is a x-axis and a y-axis. Now you take the vertical ellipse. So this is a vertical ellipse. What is the equation of that ellipse? This is equal to x square by a square plus y square by b square is equal to 1, where a is less than b. Here the major axis is this, that is equal to b dash. Now the circle whose diameter is major axis of the ellipse, that means this is the circle whose center coincides with the center of the ellipse. So the equation of this auxiliary circle is x square plus y square is equal to b square. Why? Because the distance, this distance is nothing but, this distance is nothing but small b. Total is 2b, up to that CB distance is a b. Therefore, the equation of the auxiliary circle is x square plus y square is equal to b square. So therefore, this is one auxiliary circle, another auxiliary circle. From this auxiliary circle, we have one important property. What is the properties? We know that angle in a semicircle is 90 degrees. That means, take a point here, any point on this, if you take it as a semicircle, so this is a semicircle. Take a point P, any on the semicircle, join PA and PA dash, here the angle is 90 degrees. So here also it is a point on the semicircle, join this and this is 90 degrees. Here down is also a semicircle, take a point here P, join A dash P and AP, this is also 90 degrees. Okay now, so from this, so this is a 90 degrees, 90 degrees, 90 degrees. So this is a one of the, that means taking from A and A dash as the end points, if you join that any point, you will get the 90 degrees. That means AP A dash is equal to 90 degrees. Okay, that is also one of the important properties of auxiliary circles of the ellipse. Okay, now I hope that you understand this auxiliary circle concept. Using this auxiliary circle, we are going to define eccentric angle of a point on the ellipse. Eccentric angle of a point on the ellipse. Okay, now let us continue the class. Welcome back to these concepts. A very important concept this is, so please listen carefully. Eccentric angle of a point on the ellipse. So here the diagrams, you can understand this. So x-axis, y-axis, let's see with the center of the ellipse and the major auxiliary axis. This black colored circle curve is auxiliary circle, this red colored curve is ellipse. Now let us take a point P on the ellipse. So this is a point P on the ellipse. Okay, now let us drop the perpendicular on the major axis. On the axis means major axis, that is a PN is dropped perpendicular on the major axis, and extend this NP to touch or intersect the auxiliary circle at Q. That means extend this NP upward so that it intersects that line at Q for auxiliary circle. Now here first point is the point Q is called, the first point to be remembered learned is here. Q is called the corresponding point. The Q is called the corresponding point of P. First definition. That Q lies where? Q lies on the major axis. P lies where? P lies on the ellipse. So that QPN is collinear, same straight line that lies on the same straight line. That Q is called corresponding point of P. If it is P lies here, now draw a straight line. So Q will be here. So this Q is called corresponding point of P. P will be on the ellipse, Q will be on the auxiliary circle. Okay, now? So that is the first point. The second point is to be remembered is, now join this C to the point Q. C to the point Q, that is C center of the circle. Then the angle NCQ, that is NCQ. That angle is called, let us call it a theta, is called eccentric angle. Eccentric angle of P with respect to the hyperbola, ellipse, with respect to the ellipse or with respect to the auxiliary circle. Okay. The angle made by the line segment NQ at the center is called eccentric angle of the point P. Understand this? So, see here NCQ. See here this angle is nowhere related with the P. Why? Because we are not joining CP, we are joining CQ. That's why NCQ. What is Q? Q is the corresponding point of P. So, that is called the eccentric angle of the point P. Understand this? Now, third point to be learned is, what is the range of the eccentric angle? Range means what? What is the minimum value? What is the maximum value? Okay, right. If P coincides with the vertex of the ellipse, that means if P is here, then Q is also coincides with the P, that means both P and Q is coincides, then what is the angle is here? 0 degrees. Angle is 0 degrees. So, therefore, the minimum angle is 0 degrees. And what will be the maximum angle? That means, for example, if Q is moving like this in an anti-clockwise direction on the ellipse, according to that, Q is also moves on the auxiliary circle in an anti-clockwise direction. According to that, the theta is also taking angles from 0 to 360 degrees. Therefore, theta belongs to closed bracket 0 to 2 pi radians, open bracket this is 0 to 2 pi radians. So, the minimum angle is 0. When it happens? When Q coincides with Q and P lies at the the positive end of the major axis. Okay, now? Then if P moves on this ellipse, in an anti-clockwise direction, according to that, Q is also moves on the auxiliary circle. According to that, CQ also takes the angles from 0 to 360 degrees, close bracket 0, 0 radians to 2 pi radians. Okay, na? So, I hope that you understand this concept. Okay, using that, can we take a general point on P using this eccentric angle? Okay, so that is called parametric point, and those equations are called parametric equations. Okay. So, before learning this parametric point and parametric equations, I will explain a very important point. Here I am saying P is an arbitrary point on the ellipse. Let us suppose that P is on the end of the, so if it is P lies here on one end of the minor axis P. So, then automatically Q will be here. Okay, now? Then automatically N will be here. So, see here all this, if this line, if it is line NPQ, here also NPQ. What is the ratio of NP is to NQ? NP is nothing but B. That means, of course, equation of the ellipse is x square by a square plus y square by b square is equal to 1. Of course, a greater than b. What is a NP length? NP is nothing but semi-minor axis. Nothing but B is to. What is a NQ? NQ and NA both are same. NQ and NA. Why? Because this is the radius. NQ is the radius. NA is also radius whose length is semi-minor axis. That is A. So, from this you say that NP by NQ is equal to B by A. Put it like that, put it like that. We will make use of this result. So, always remember that wherever P and Q may be, wherever the ratio of the NP and NQ is always B is to A, B by A. Understand? So, if it's P maybe here, maybe here, maybe here, maybe here, anywhere, NP by NQ is equal to B by A. NP by NQ is equal to B by A. Now, clearly you are seeing a triangle CNQ. You are seeing a triangle CNQ. CNQ is a right angle triangle, obviously. Right. Then what is cos theta? In trigonometry, we will go first in trigonometry. What is cos theta? Adjacent angle, that is adjacent side by hypotenuse CQ. So, from this CN is equal to CQ into cos theta. Similarly, sin theta is equal to opposite side, that is NQ. NP by NQ is equal to B by A. Okay now. Right. Sin theta is equal to opposite side by NQ by hypotenuse CQ. This implies NQ is equal to CQ into sin theta. NQ is equal to CQ into sin theta. Here CN is nothing but x coordinate of both the points P and Q. Okay now. Here NQ is nothing but y coordinate of the point Q. Okay, let us see this. We know that NP by NQ is equal to B by A. So, now we will come back here again. So, we will come back here. NP by NQ is equal to B by A. Okay. So, we will make use of some results here. So, NP by NQ is equal to B by A. So, from this implies NP is equal to, so I am taking this NP, I am taking NP is equal to B by A into NQ. NP is equal to B by A into NQ. This is same as, this is a B by A into, what is your NQ? Your NQ is nothing but CQ into sin theta. Okay now. Right. So, if you observe, already we know the ratio, that is NP by, in place of CQ. So, in place of CQ, so can we, if it is a coincides with here A, the length will be A, no? So, that means if, for example, if it coincides with A, if it is, see here, CQ is and CA both are same. CQ length and CA length both are same. Why? Because Q lies on the auxiliary circle. So, CA length is A. So, therefore, so this is nothing but B by A into A sin theta. Therefore, AA will get cancelled, B sin theta. So, B sin theta. So, that means what is NP? NP is equal to, we got that, B sin theta. So, here NP, the length NP is nothing but y coordinate of the point P. Here NP is nothing but y coordinate of the point P, that we got as b sin theta. So the point P, y coordinate we got b sin theta. Next we will take it as a NP is over, no. Next we will take a Cn. Here already we got Cn is equal to Cq into cos theta. This implies Cn is equal to Cq means how much here? Cq and Ca both lengths are same. Why? Because both are radii of the same circle. That is equal to a cos theta. Therefore, what is Cn? Cn is nothing but x coordinate of the point P. Cn is nothing but x coordinate of the point P. That is given as a cos theta. Therefore, any point a cos theta and b sin theta, this is called where theta lies between 0 to 2 pi. 0 to 2 pi. Theta belongs to 0 to 2 pi radians. What is theta? Theta is the parametric angle of the point P. Eccentric, sorry. P is the eccentric angle of the point P. So that lies between 0 to 2 pi radians. So any general point P on the ellipse x square by a square plus y square by b square is equal to 1 where a greater than b can be taken as a cos theta comma b sin theta. So this is the proof of that concept. So this is the whole proof. Okay now. So this a cos theta comma b sin theta is simply, sometimes it is denoted as theta. Simply it is denoted as theta. Theta means a cos theta comma b sin theta. Alpha means a cos alpha comma b sin alpha. Like that we will take. So on this concept there is a very, very important one point is there. So let us discuss that. Now there is a question arises. Sir, if our ellipse is with the standard form whose center is 0 comma 0, that is equation of the ellipse is x square by y square by b square is equal to 1. The any point we take it as a cos theta comma b sin theta, where theta belongs to 0 to 2 pi radians. Theta is the eccentric angle of the point P. That is very clear. If the ellipse is shifted, the center is shifted to h comma k. If the center is shifted to h comma k, okay, then how to take the point P? Already I told in the previous concept today's starting class, the increment is h comma k. So for this, that means if the x minus h whole square by a square, if your ellipse equation is y minus k whole square by b square is equal to 1, then any point on this ellipse can be, general point can be taken as h plus a cos theta k plus b sin theta. That's all. Add hk. For x you add h, for y you can add just increment. That's all. Okay now? Right. I hope that for all equations are also, for here, for theta is same, 0 to 2 pi radians. Okay, right. I hope that you understand this point. So let us see one more point. Welcome back, one more point. So let us take an ellipse here, x square by a square plus y square by b square is equal to 1. Either a greater than b or a less than b, nothing wrong in it. So let us take a circle intersects the ellipse at 4 points P, P1, P2, P3, Q3. A circle. So don't think that it is not an auxiliary circle, any circle, any circle. It intersects the ellipse at 4 distinct points obviously, P1, P2, P3, P4, P4. Okay, right. P1 is a point on the ellipse. Let's its eccentric angle is theta 1. Okay, again we have to take the auxiliary circle and we will extend that is a Q1 and join with the center, all those things that I am not drawing there. So the eccentric angle of P1 is Q1, the eccentric angle of P2 is Q2, the eccentric angle of P3 is Q3, let the eccentric angle of P4 is Q4. then the relation between this peak theta 1, theta 2, theta 3, theta 4 are theta 1 plus theta 2 plus theta 3 plus theta 4 is equal to even multiple of pi, that is 2n pi, that is theta 1 plus theta 2 plus theta 3 plus theta 4 is equal to 2n pi. That means the sum of the 4 eccentric angles is either is equal to 2 pi or 4 pi or 6 pi, whatever may be that. Okay, now understand? So I hope that you understand this concept, and in the tomorrow's class I am going to explain what is the equation of the tangents and the equation of the normals, how to derive the formulas, all those things I will explain in the next class, and until then all the best.